Hi, this is still section 6.3, example number 7. And what we're going to do is we're going to find a direction angle of vectors. All right, so we want to do two of these. First one, I have a vector u that has a linear combination of 3i plus 3j. Remember, when we're dealing with linear combinations, it's the same thing as saying that the terminal side is at 3, 3. And this vector is in standard position, so its initial point is at 0, 0. And for the second vector, vector v, it has a terminal point at positive 3, negative 4. Okay, and again, both of these vectors are vectors in standard position, so both of the vectors' initial points are at 0, 0. All right, so I want to find the direction angle that is created by the vector and the positive part of the x-axis. So what I'm going to do with the first one is I'm going to go ahead and graph the first one. So it has a terminal point at 3, 3, which would be right there. And this is what the vector looks like. And I want to find the direction angle created by the positive part of the x-axis and that vector. So remember, the positive part of the x-axis is right here. So I want to know what is the angle measure here. Now, if I create a right triangle out of this, I know the length of this side of that right triangle is 3, and the length of that side of that right triangle is also 3. So if I want to find the measure of this angle, then I'm going to use tangent. Tangent is equal to opposite over adjacent. Opposite over adjacent, so the tangent of angle theta is equal to 1. And if I go over to my calculator now, we're going to go ahead and put this in degree, and my calculator is already in degree mode. So I'm looking for the angle measure, so we're dealing with arctangent of 1. And I get a 45-degree angle. So angle theta is equal to 45 degrees. All right, simple, easy enough. Let's do the second one. The second one had a terminal point at 3, negative 4. Yes, 3, negative 4. So let me go ahead and create that. So 1, 2, 3, down 1, 2, 3, 4. So there's your terminal point. Okay, I'm not sure if you can tell, but this is purple, that's orange, so we're dealing with purple now. And I want to find the measure of this angle. All right, we'll call this angle beta. Again, if I create a right triangle out of the terminal point and the positive part of the x-axis, I know the length of this side is 3. I'll just keep that 3, and the length of this side is going to be 4. So what I'm doing, and again, I can only find this angle right here for right now. So from this angle, now this is the reference angle, and this angle, I'm going to use tangent, opposite over adjacent. So tangent of that angle, let's call that alpha, is equal to opposite side. Now, I do know that since I'm in quadrant 4, tangent is going to be negative. It's going to be negative because of the negative 4 over positive 3. Okay, if I don't remember the fact that this is going to be a negative 4, no big deal. I just know that tangent is negative in quadrant 3. All right, so let's go ahead and do the arctangent of that. So that's going to be negative 4 over 3, and that gives me a negative 53.1 degrees. That's the measure of this angle. Remember, it's negative because we're going clockwise, so it's negative going this way. But I don't want to measure this angle. I want to measure this angle. So this whole entire thing from here, this whole entire angle from here to here is 360 degrees. And if I subtract that part, that would give me what I need. So 360 degrees minus 53.1 degrees. And that looks like it's going to be like 206.1 or something like that, or 306.1. The 360 minus 53.1, going to be 306.9. Where I'm getting 0.1 from. All right, so that is how you find the direction angle of any vector. You obviously need to know what the terminal point is. Okay, so I hope this helps you out. Again, if you need help, please reach out.